Navajyoti's, Ram Maruti's family. Okay, so this is the question for you now. So here the question says is using Euclid division lemma, show that square of any positive integer is of the form 3p or 3p plus 1. I repeat, by using Euclid division lemma, you are supposed to prove that square of any positive number, you take a positive number, square of any positive number, if you square that one, we should get in the form of 3p or 3p plus 1. Okay, let's start working. If A and B are any two positive numbers, if A and B are any two positive numbers, such that A is greater than B, we have taken A such that it is greater than B, right? When A is divided by B, if A is divided by B, that is when A is divided by B, this is what we are saying, right? Let Q be quotient and R be remainder. Okay, so when A is divided by B, here comes the quotient Q and here comes the remainder R. Okay, why I'm writing all this stuff, right? I have taken two numbers A and B such that A should be greater than B, okay? And when A is divided by B, Q is the quotient, R is the remainder, right? Now, what did Euclid say regarding that? According to Euclid's, that's what? Euclid's division lemma, according to the division Euclid's lemma, right, what he says, A is equal to BQ plus R. That is what our A is now. Means the A here equals B into Q. You multiply that B into Q, yes, B into Q, plus if you multiply B into Q, we get it as BQ. Yes, the product is BQ. For that product, you add the R. Then you will get back that A. That is what you see. A equals B into Q, that is BQ. Add the remainder, we'll get it. If you want to show me with the help of an example, I can show you. You can take, if you take a number 7, if you divide it by 2, 2 3 is 6 and the remainder is 1. Yeah, that's true. Now you take that 7. 7 is nothing but 2 into 3, yes, plus what is the remainder here? 1. Okay, that's what Euclid division lemma says. This is the definition, this is the proof, and this is the example. This is said by Mr. Euclid division. But one more thing, he said one more thing. What he says, the remainder, whatever we are getting, is always less than the number who is dividing. That is what? Where, right, the remainder R is always less than the B. The remainder R is always less than the B. Okay. And one more thing he said, the remainder will be always greater than or equal to 0. This is the condition given by Mr. Euclid's. So, this is the theorem of Euclid's. This is the lemma. Lemma means rule. Of what? Of the division. So, Mr. Euclid set a rule regarding the division. What is that rule? If A is greater than B, A and B are 2, divided, we get this. Okay, let's apply this one for the numbers what he has given. Right, applying Euclid's division lemma for, right, what is the numbers we are taking? We are taking A as A only, but B as the number here is nothing but 3. Let's take the number as 3. Okay, let's take the number 3 and check it out whether we are getting the number like that or not. So, which implies if we apply A in the place of A and B in the place of B, what is according to Euclid? A is equal to, in the place of B, what we are keeping? 3. 3Q plus the R. Okay, then what is R? Just now I said the remainder will be always less than the number present here. What is the B here? 3. Then what might be the reminders? Which implies reminders may be what are the numbers less than 3? 0, 1, 2. These are all the numbers what we get. Okay, now let us substitute 0 in the place of r and square it. Let us substitute 1 in the place of r and square it. Let us substitute 2 in the place of r and square it. Let us see that one. Okay, we are taking the first one. Case 1. Right, what is a for us? A is equal to 3q plus r. But in the place of r, what we are taking, it's nothing but the 0. Okay, now a is equal to 3q plus 0. A is equal to 3q. Yes, we got the number. But what he wants? He wants us to square. This is the number a. Now let's square the number. Square the number. Square the number. What's the number here? Square the number a. That is, a square is equal to 3q whole square. A square is equal to, if you simplify, 9q square. Now the number is a. Square of the number is a square. Now the answer can be write in the form of 3p or 3p plus 1. That is the given question. Can we write this 9q square as 3 into p? Let's see that one. So a square, can I write 9 as 3 into 3q square? Yes, very good. Now a square, can I take this total as 3q square? Now a square is equal to, now I like to write it as 3p. Where that p is nothing but the number which is in the bracket, that is 3q square. So what we have seen, the squared number, the squared number, right, is in the form of what's that? 3p. Yes, the condition is satisfied. So when r is equal to 0, right, a is equal to 3q plus 0, 3p squared it. Yes, I have written in the form of 3p. Case 1, yes, it is satisfied. Now let's get back to the case 2. What's the case 2? What is r? Here, first one r is equal to 0. Next one r is equal to 1. Let us plug in r ke badle mein 1. So, a is equal to 3q plus r is the given question. A is equal to 3q plus 1. In the place of r, let us substitute. What's that? 1. Okay, a is the number. But what is the condition? Square of the number. We have to check it out. After squaring, what do you get? So, right, square of the number. Square the number. Square the number a. Let's square that one. We will see what will happen. So a square is equal to, what is the number here? 3q plus 1. Let's square that. After squaring, what we will get? Let us check it out. So a square is equal to, now is it looking in the form of a plus b whole square? Yes. It's nothing but a, first one square plus the second one square plus 2 into the first one into the second one. A square plus b square plus 2 into a into b. What is a here? It's nothing but 3q. What is b here? It's nothing but 1. Let's simplify and check it out whether we can write in the form of 3p or 3p plus 1. A square is equal to, the square comes to both, 9q square plus 1 square is nothing but 1. 2 into 3 into 1, it's nothing but 6, and it's nothing but q. Okay, 2, 3, 6, 6, 1, 6, and the cube drop. Now, let us check it out. Can we write this either like a 3p or 3p plus 1? Let us check it out. You can observe the word 1. Send that 1 to the side. A square is equal to 9q square plus 6q. I have shifted to the corner of the sum. Why? Because we are able to see the 1 there. Now, almost 1 is there, but we need in the form of 3 into something. Let us think about these two. Can we take 3 common from that one? Is 3 the factor of 9 and 6? Yes. So, I am taking as common. If I take 9 can be written as 3 into 3q square plus 6 can be written as 3 into 2q, of course, plus 1. I am taking 3 out here. So, a square, if I take 3 outside, what is left over? 3q square plus 2q plus 1. Okay, now the total stuff, whatever is present inside, a square is equal to, I like to write this total as p plus 1. So what is that p? The one which is inside the bracket. So right, which implies right, p equals 3q square plus 2q. So can we say that squared is the a square is in the form of 3p plus 1. Okay, now still we are not yet done with the other total stuff. Case 3. We are going for case 3. That is, a is equal to, as we know, a is equal to 3q plus r. 3q plus r. Now a equals 3q. In the place of r, earlier we placed 0. Later on 1. Now let's place 2 there. Okay, we got what is a, but we need to square that. Square the number. Square the number. So bracket square is equal to the square of the number. So what's the number here? It's a. Here it is nothing but 3q plus 2. Here a square is equal to a square b square plus 2a into b. That's what a plus b whole square is. Now let us plug in the value. This is a, this is b, this is a, and this is b. Now let's simplify that. It becomes, the square comes inside 9q square, and 2 square is nothing but 4, and 2 3 6, 6 2s 12. Right, it's nothing but 12q. Okay, now the trick is very important here. Now what I am doing, I am taking the number 4 to the last. Okay, 9q square plus 12q plus 4. No issues with that one. Now I started thinking, what should be the last there? The last should be 1. And the remaining all, what are those? Multiples of 3. I started thinking. So planned way, what I am doing, 9q square, no issues. Right, 9q square plus 12q. I am writing that 4 as 3 plus 1. That's the trick. 3 plus 1. The required plus 1. See here, the required plus 1, we made it to the side. Now you check it out. Is 9 to a square? Do we have 3 as a product there? Yes. If you check it out, from these 3, from the last 3's here, right, from these all, I can take it as 3 common. If you check it out, so we are having it as, this one will become it as something like 3q square plus it is nothing but 4q plus 1. Of course, the last one, the plus 1 is always here. Check it out. The 4, I am writing it as 3 plus 1. I made that 1 to the side. Then from the next 3, I took 3 as common. Now very simple stuff. Right, it's nothing but 3p plus 1. So the entire stuff, whatever is there, where p is equal to 3q square plus 4q plus 1. So what is this one? Is it the square? Right, the square is also in the form of 3p plus 1. So what did we conclude? We conclude that square of a number, conclusion. If you want, you can write the conclusion. What's that? Square of a number in the form. Right. What's the form here? It's nothing but 3p or 3p plus 1. So that's what we proved. The logic here is reminder to right. Lemma, that's nothing but Euclid division lemma. Reminders are 0, 1, 2. I took with the 0. Okay, I squared it and I have written in the form of 3 into something. Now r I took it as 1, right? I plugged it, squared, applied the formula a plus b whole square. I took the 1 to the side. Then from the first 2, I took 3 as common. Right, next one, r is equal to 3. Here, what is the next one? R is equal to 2. I plugged in 2, squared it. I got 4. I took the number to the corner. Then the 4 I have split it as 3 plus 1. Now I took the 1 to a side, and from the first 3 I took 3 as common. That's the simple logic. Then we can prove that the square root of a number can be written in the form of either 3p or 3p plus 1. Hope you are able to understand. In this channel, I have been placing both math and science videos.